This is kind of cool. There's a bunch of different ways. Now that you guys are all experts on networking, you know, we went through all the different vernacular, and it sounded like you were getting excited about it, at least, you know, from all the comments and chatter on the chat window. Now we can put some lipstick on the pick and actually go in and figure out how to actually secure those networks. And so we mentioned the timing of it. In 1980, February of 1980, that's right, can't make this stuff up. Check this out. The IEEE came up with the 802.x protocol. And so that established a baseline way for LANs to communicate in February of 1980, the 802.x LANs. So what I did not mention there is wireless, right? Because it wasn't until the 11th iteration of that wireless came out. So, you know, again, February 1980, 802.11, the 11th iteration or amendment of it, that wireless came out. And so we commonly know that now as wireless Wi-Fi. But the 802.1x is for LAN, and so local area networks. And so anytime you see 802.1x, you should be thinking of ways to communicate over LAN as well as network access control, or NAC. So guidance on how we should communicate through on network access control. And, you know, in order for us to do certain secure components, whether it's hardware or software, typically we will run a firewall. And we're going to go through each one of these firewalls here, and I'm going to give you some more things that you can prepare and study for. But before we do that, we have to talk about segmentation. Why would we need to segment networks? Why would we need to segment networks? Shelby, that's the best caramel macchiato I've ever had. Thank you. Yeah, yeah. In order for us to really try to develop a secure network, we want to try to consider the broadband. We want to try to consider not the broadband, the bandwidth. We want to try to consider the bandwidth. We want to consider, you know, what is happening in certain segments. You know, what type of operating system, maybe departments and the like. And so we create these things that are called VLANs. And so these virtual LANs are inside of our network. It can be company departments or isolated labs. You know, we can put SCADA systems or industrial control systems, maybe servers, media nets, video teleconferencing. I mean, you can create all these different VLANs, and it can be quite organized, or it can be a hot mess, depending on who sets it up and how well they know how to do it. And so, for instance here, VLAN 10, we might put all of these IP addresses on VLAN 10. VLAN 20, we might put all of these on there. VLAN 30, we might put all of these. And then, you know, so that means that even though people in finance might be in different buildings, we still logically put them on the same virtual LAN. So the assignments would be over different subnets. And we do that by creating these things called zones. And so usually these zones are a way that we can try to generalize using VLANs, whether it's secure components, the wireless maybe, or this next thing that's called the demilitarized zone. So check this out. Usually the DMZ is the place between North and South Korea, right? Or maybe between East and West Berlin. Well, that's in the political climate. And so for purposes of our discussion here, a DMZ usually has three interfaces. It'll have the WAN, the internet, the intranet, and some sort of what we typically will refer to as an extranet, right? An extranet. So we usually will place these things called bastion host in the DMZ. So these bastion hosts typically have most services disabled on them and are put into this DMZ. So usually most services are disabled. The easy way that I remember this word right here is they're kind of like a bastard child, if you will. And forgive me, I know that it's could be offensive. So maybe we should say that this is PG-13 instead. So there's a bastard device that's left alone to fend for itself out here, right? So the bastion host, and hopefully you never forget that now, the bastion host is put out in this DMZ because it's got to fend for itself out there. And so the DMZ is things that we absolutely care about, but like web applications or maybe web services or things like that, websites of some kind, where anybody on the internet can hit up the DMZ and whatever devices are there will get cattle prod. They will get poked. They will get scanned. It's likely they may end up getting compromised. And so what we don't want is we don't want those devices to have hooks to the internal network. And so sometimes we have gotten incident responses from clients before, or they weren't clients and then they became clients, with things like remote desktop servers that are sitting in the DMZ, where all day long China and Iran or North Korea are scanning that RDP server, that remote desktop server, and finally, maybe after a year of trying to brute force it, they're able to pop it. They're able to gain access to it, and that remote desktop server is typically used by admins, and then it can pivot into the internal network. So typically we run a bastion host out there that is a host that only has a few services that run on it, because we do not want to allow anything that's in the DMZ to connect internally unless we are super sure that it is secure.